Welcome to the polynomial class. Okay. In this video, I want to uh, discuss some problems about polynomials, which are mainly for the Math Olympiad preparation as well as any of the engineering entrances you want to participate later. Okay. So this is meant for multiple classes from 8th class to 12th class. Everybody can use these problems actually. They are very useful to understand the polynomials. Polynomials can come in physics also, as you know, physics and math. So if you know all these basics, then it will be easy for you to solve several problems. Okay, so let's go. So as I said, this is helpful for the students from class 8 to class 12th. Okay, so let's see. Let's just brush up the basic definitions of polynomials, what we learned. So best thing is I have made a polynomial class for the Telangana uh, chapter 3 polynomials chapter actually. So that has all the basics about the polynomials. So you can refer to the class for details, but I'll just put the summary here and then go into the problem. Okay, so the basic definition of polynomial is it will be in the form of p of x equal to a0 x power n, a1 x power n minus 1 up to a n minus 1 x plus a n. Okay, in this one, the most important things are if it is nth degree, then a of 0 should not be equal to 0. Okay, if a of 0 equal to 0, then it's not nth degree, it is n minus 1 degree. Okay, and a0 to an are all real coefficients. Okay, okay, so this is the basic definition of a polynomial. Okay, a polynomial of degree n can have at most n zeros. Okay. 0 is the value of p of x at which the value will become 0. Okay. So if let's say given polynomial p of 1 equal to 0, then 1 is a 0 of the polynomial. So a polynomial of degree n can have at most n zeros. Need not have all n zeros. It can have 0 also, no zeros also. Okay. It can have at most n zeros. Now, how to understand polynomial from the graphs, various graphs? Okay, it's a quadratic polynomial. It looks like the curve looks like a bell curve here. Okay, either upside or upside down. Okay, if you see how many times it crosses the x-axis, touches the x-axis, those are the real zeros of the polynomial. So this has two zeros, this has two zeros, this has only one zero. Okay, this has only one zero. This has no zeros. These two graphs don't have any zeros for the polynomial. So from the graph, this is how you can understand zeros of the polynomial. It is true for not only quadratic, any polynomial. Okay, this is a cubic polynomial. It looks like this. Obviously, you can see there are three zeros, minus 2, 0, and 2. These three zeros are there for the graph. How to construct a polynomial? Basically, you take the equation and take some values for x and calculate what is the value of the polynomial. You call it y. Then x comma y, that is the number you have to draw. Okay. Yeah. So just check how many zeros for this below graph. Simple exercise. This has only one. Okay. This has two zeros. This has three zeros. One, two, and three. This has only one zero here. Linear polynomial. This is a quadratic polynomial has one zero. This is 1, 2, 3, 4. Okay, four zeros are there. Okay, so that is how you can understand the graph. Okay, relationship between zeros and coefficients of polynomial. If you take a linear polynomial, that means ax equal to b. Zero is obviously you equate ax plus b equal to 0, then it will become x equal to b minus b by a. So this is a 0. Okay. For the quadratic, if it is in the form of ax square plus bx plus c, then sum of zeros, that is if alpha and beta are the zeros of this polynomial, then alpha plus beta equal to minus of x coefficient by by x square coefficient, that is minus b by a. Okay. Product of zeros, that is alpha into beta equal to c by a, constant term by x square coefficient. Okay. Now, cubic polynomials, I think similar relationship exists. Okay. If you take p p of x equal to ax cube plus bx square plus cx plus d, we can find out the relation of zeros and the coefficients. Okay, how to do it? If alpha, beta, gamma are roots or zeros of the polynomial, then polynomial can be written as x minus alpha into x minus beta into x minus gamma. Okay, now you multiply, you will get the polynomial. Okay, since it is ax cube, we want not 1 as this one. So you multiply a with each term. Okay, each term you multiply with a, and then what you will get is this uh, expression, polynomial expression here. Now you relate what is the relationship? Alpha plus beta plus gamma into minus a equal to b, right? So alpha plus beta plus gamma equal to minus b by a. Then alpha beta plus beta gamma plus gamma alpha equal to c by a. And then alpha beta gamma equal to minus d by a. Okay? So this is how we can derive it. Okay. Uh, this is one of the very important polynomial, or I mean, I don't know what you call algebraic rule. Okay. This keeps on coming in Olympiad problems several times I have seen, and in other exams also. If a plus b plus c equal to 0, if a plus b plus c is equal to 0, then a cube plus b cube plus c cube equal to 3abc. Okay. And reverse. If a cube plus b cube plus c cube equal to 3abc, then either a plus b plus c equal to 0 or a equal to b equal to c. Any of this is possible. Okay. For the proof of this one, you can refer to my previous videos. I just showed the proof of this one. This is one very important thing to note down. Several times I have seen in Olympiad problems came based on this rule. Okay. So remember this. Try to prove it yourself. It's very easy. It's not very complex. Okay. Now let's go into the polynomial problems. Okay. If x1, x2 to xn be a sequence of integers such that xi is in between minus 1 and 2. Okay. For I equal to 1 to n. Okay. So, and this is one condition given. Second condition is x1 plus x2 plus x3 up to xn equal to 19. x1 square plus x2 square plus dash 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 up to xn square equal to 99. Then determine the minimum and maximum possible values of x1 cube plus x2 cube plus dash 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 up to xn cube. Okay. So let's see how to do this. So first thing is you understand the x value is between minus 1 to 2. So how many possible values are there? Minus 1, 0, 1 and 2. Correct? There are 4 values possible for x. Okay. Out of that, if you take 0, it does not add any value to any of the equations given here. Okay. 0 here, 0 square, 0 cube does not add any value. Correct? So let's ignore. Let's find out how many i's are there which add value to this given equation. That is minus 1, 1 and 2. Okay. So many number of multiple number of these three values will be there. Correct. So let a comma b comma c denote the number of minus 1s, 1s and 2s in the sequence. Okay. So many are there. Okay. Sum of so many things is equal to 19. That is the second condition. Correct. So minus a times minus 1. Okay. There are a number of minus 1. So minus a, b number of 1s, that is b into 1, plus c number of 2s, that is 2 into c, equal to 19. This is the first, second equation which is given here. Okay. And this equation you can rewrite as a number of minus 1 square, that is 1, plus b number of 1 squares, correct? And c number of 2 squares, that is 4c, equal to 99. Okay. Now you understood how we derived these two equations. Now you have two equations in three variables. You can easily bring them into a dependency. Okay. So now I have rewritten b equal to 59 minus 3c and a equal to 40 minus c. I wrote b and a in terms of c. Okay. Now, if you check the range, okay, C is between 0 and 19. How did I come to this conclusion here? If you see this equation here, B equal to 15 and minus 3C, correct? What are ABCs? ABCs can be negative? No, there cannot be negative number of minus ones and twos, right? They have to be positive. They cannot be zero also, in fact, right? So if C is 20, then B is negative, minus 1. It's not possible. So maximum value of C is 19. Okay. Minimum value obviously 0. Correct. So C is between 0 and 19. Okay. Now note down this condition. Now we need to find out the range for the cubic equation, right? So cubic equation is a number of minus 1 whole cubes, correct? That is minus a. B number of minus 1 cube, that is b plus b. C number of 2 cubes, that is 8c. Okay, so sum of these three equal to, okay, sum of these three equal to 19 plus 60. How did I come this? I just replaced A and B with the C definitions here. Okay, that is 15 and minus 3c and A is 40 minus c. If I replace this and simplify, I'll get 19 plus 6c. Okay, now I know the range of C, that is 0 to 19. Correct. So lower bound is at C equal to 0. At C equal to 0, lower bound is 19. Correct. 19. This becomes 0. So 19 is the lower bound. And upper bound is at C equal to 19. Okay. I'll get 133. Okay. So this is the lower bound and upper bound for the given cubic expression. Okay. So understand the polynomials in this way. Okay. Let's see more problems. A polynomial 1 minus x plus x square minus x cube plus dash 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 minus x power 17 may be written in the form of a0 plus a1y plus a2y square dash 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 up to a17 y power 17, where y equal to x plus 1 and a's are constants. Find a2. We have to find the value of a2. Okay. Yeah. So basically those two expressions are equal. It is written in that other form. So you need to find a relation between x and y, right? I mean, y equal to x plus 1 is given. So you need to find the polynomial constants. What will be the constants? Okay, let's see. First thing, take f of x, which is given here. We will try to find out, we will rewrite this and find out another definition of f of x. Okay. So you multiply x into f of x, then it will become, each term will be multiplied with x, right? So x minus x square plus x cube minus dash dash up to minus x power 18. Okay. Okay. You add above two equations, f of x and x f of x. What you will get is 1 plus x into f of x equal to, only things remaining, the rest all gets cancelled. Minus x is here, plus x is here. Plus x square minus x square. So things get cancelled. Only thing will remain is 1 minus x power 18. Okay. This implies f of x equal to 1 minus x power 18 divided by 1 plus x. So now we redefined f of x, okay, in a very easy way. Now we can replace whatever we want, right? Y equal to x plus 1. So we can replace this value. Now it is given that y equal to x plus 1. So that means x equal to y minus 1. So f of x equal to f of y minus 1, which is equal to 1 minus 1 minus 1 minus y whole power 18 divided by 1 minus 1 plus y. Okay, which is equal to 1 minus 1 minus y whole power 18 divided by y. Okay. Now if you see, this is nothing but this expression, right? In terms of y. Correct? This is the f of x definition in terms of y. Now, where is a2? a2 is quotient of y square. a2 is quotient of y square. So here, where is the y square term in this one? Since we have a denominator of y, you need to get y cube term from the numerator. Then it will become y square. Correct? Where is the y cube term in this? Okay, so you need to find 1 minus y whole power 18 y cube term. Correct? Correct? A2 is y square quotient. That is, we need to find y cube quotient from the 1 minus y whole power 18. Right? That is nothing but, if you know the binomial theorem, 18C3. That's what the cube you will get, which is equal to 18 into 17 into 16 divided by 1 into 2 into 3, which is 816. This is the A2 value. Okay. Next. Given that 2x square minus 5x minus a equal to 0 is a quadratic equation in x, a is a parameter or some value. Okay. If the ratio of its roots x1 is to x2, if x1 and x2 are roots of this quadratic equation, then x1 ratio to x2 equal to 2 is to 3. Find the values of x2 minus x1. Okay. So normally what we try to do is we try to find out uh, x1 plus x2, we know it is nothing but 5 by 2, and x1 into x2, which is minus a by 2. Then we try to find out values of x2 minus x1 from that relation. Okay. But since it is the ratio given as 2 is to 3, there is a easier way to find out. Okay. Okay. Easier way is x1 is to x2 equal to 2 is to 3, which means we can assume that x1 is 2k, x2 is 3k. Correct? Now, x1 plus x2 equal to 2 roots equal to 5k, right? 2k plus 3k, 5k, which is equal to, from this uh, quadratic equation, sum of 2 roots equal to minus of minus 5 by 2, which is 5 by 2. Correct? So, which means k equal to half. Right? Now, we got the k value. Now, x2 minus x1 equal to 3k minus 2k, which is nothing but k. So, we already know the value of k, that is half. So, this is the answer. So this is easy way to solve this problem rather than finding from x1 plus x2 and x1 x2. Next. Given the two roots of equation x square plus px plus q equal to 0 are 1 greater than the two roots of equation x square plus 2qx plus half p equal to 0 respectively. Okay. Find the solutions to each of the two equations. Okay. So this is okay. Let's say a comma b are the roots of second equation, that is x square plus 2qx plus p by 2 equal to 0. Then a plus b equal to minus 2q. Okay. And ab equal to p by 2. Okay. Now, a plus 1 and b plus 1 are roots of first equation, right? That means that's what is given. So, a plus 1 plus b plus 1, that is a plus b plus 2 equal to minus p. Okay. And a plus 1 into b plus 1 equal to q. Okay, now you just expand it and substitute, you will get the values. Okay, a plus b equal to minus 2q. So minus 2q plus 2 equal to minus p. And if you expand this, ab plus a plus b plus 1 equal to q, which implies ab is p by 2 and a plus b is minus 2q. So plus 1 equal to q, which implies p plus 2 equal to 6q. Okay, now from these two equations, okay, that is 2q minus 2 equal to, okay, equal to 6q minus 2. P basically, p value I am equating. Okay, this implies 4q equal to 0 and q equal to 0. So p equal to minus 2. Okay, now we got p and q values. Okay, which means you substitute it here, what you will get is x square minus 1 equal to 0. That means x equal to plus or minus 1. Okay, this is the roots of the second equation. Now, first equation roots are, obviously you don't need to actually find out, they are plus 1 to this value, right? Or you substitute in the equation and you can find out x roots are 0 and 2. Next, just check the previous answer. X equal to, for the first equation, you have the roots of 0, comma 2. Okay. Given that alpha, beta are the real roots, the real numbers of x square minus 2x minus 1 equal to 0. Find the values of 5 alpha power 4 plus 12 beta cube. Okay. So these are the very common questions in Olympiad. So you need to really look at the expression which you want to evaluate and see how you can go very close to that expression. Okay. Here we need to find out alpha power 4 and beta power 3, two values separately. How can you do that? Okay. So you need a equation in alpha, you need a equation in beta. How do you do that? We know that alpha and beta are real roots. So you substitute alpha in the equation. Okay. Since alpha is the root of this quadratic equation, alpha square minus 2 alpha minus 1 equal to 0. So alpha square equal to 2 alpha plus 1. So similarly, okay, or you square it basically, alpha power 4 equal to 2 alpha plus 1 whole square, which is nothing but 4 alpha square plus 4 alpha plus 1. Now alpha square here already I have value in terms of 2 alpha plus 1. So I replace it. So finally, alpha power 4 is nothing but 12 alpha plus 5. Okay. So similarly, beta is the root of this expression. So beta square minus 2 beta minus 1 equal to 0. So beta square equal to 2 beta plus 1. So beta cube is nothing but 2 beta square plus beta. Okay. So beta square I will replace. So 2 into 2 beta plus 1 plus beta or 5 beta plus 2. Okay. So these are the two values. Now given expression, you go to the given expression and evaluate 5 alpha power 4 plus 12 beta power 3 equal to 5 into alpha power 4 value I replaced here and beta power 3 replaced here, which is nothing but 60 alpha plus 60 beta plus 49. Now it's easy, right? Take 60 common, alpha plus beta, okay? And alpha plus beta is how much? Is minus of minus 2 by 1, that is 2. So 60 into 2 plus 49, that is 169 is the answer. Okay, next. What are the coefficient of x power 4 and x power 3 in x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5? Okay. So you look at carefully, they are asking coefficient of x minus x power 4 and x power 3. Okay. So if you multiply this whole factors, okay, to get x power 4, you need 4x, right? X into x into x into x, and other one should be a constant, correct? Similarly, you take x into x into x into x, then one more constant is this one. So all sum of all constants is the coefficient of x power 4, correct? So this is very important for all such problems. It is very easy to look at the factors and then determine the coefficient. Okay. So x power 4 coefficient is just sum of all constant terms here. Okay. So that is minus 1 plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 5, that is minus 15. Okay. Now x power 3. For x power 3, what you need is basically 3x, then two constants. Correct. So that is sum of product of two constants. Okay, continuously. Then you will get the x power 3 constant, that is coefficient, that is minus 1 into minus 2 plus. Okay, I just removed negative sign for all because both are minus. So minus into minus will become plus. So 1 into 2, 1 into 3, 1 into 4, 1 into 5. Okay. Then 2 into 3, 2 into 4, 2 into 5. 3 into 4, 3 into 5. 4 into 5. Okay. If you sum up all of this, then you will get 85. So this is the answer. Okay. Next. If alpha beta are roots of ax squared plus bx plus c equal to 0, then find the value of 1 by a alpha plus b plus 1 by a beta plus b. Okay. So this problem, you look at the denominator first. So both the denominators look very similar, except that if you consider this as x, then it is axb. Both are same. Okay. You just have a root substituted in place of x. Correct. So you need to, how do you get ax plus b then here? You take common, x common from these two terms, you get ax plus b, right? So that should give you a hint. If we just follow that hint, alpha beta are roots of this equation. So first you substitute alpha, you will get a alpha square plus b alpha equal to minus c, or a alpha plus beta equal to minus c by alpha. Similarly, a beta plus b equal to minus c by beta. Okay, now you just need to do 1 by this value and then sum up, right? So you get reciprocals of these two values and sum up. Minus a by c minus alpha by c minus beta by c, which is minus of alpha plus beta by c. Alpha plus beta are the roots of sum of roots of the equation, which is minus b by a. So if you substitute, what you will get is uh, b by ac. This is the answer. Okay, next. If alpha beta are roots of x square plus ax plus b equal to 0, then prove that alpha by beta is the root of equation bx square plus 2b minus a square x plus b equal to 0. Okay, yeah, let's see. So from first statement, alpha beta are roots of x square plus ax plus b, we can derive that alpha plus beta equal to minus a, correct? And alpha beta equal to b. We can also derive alpha square plus beta square. You basically square it and substitute this value, you will get alpha square plus beta square equal to a square minus 2b. Okay. Now what we need is alpha by beta, right? Since alpha by beta is root of this expression, substitute it. Okay. If you substitute, what you will get is b into alpha square by beta square, 2b minus a square by alpha by beta plus b. Okay, which is equal to beta square is the common LCM. Then b alpha square plus 2b minus a square into alpha beta plus b beta square. Okay, that you just bring all alpha square plus beta square, alpha plus beta terms together. What you will get is b into alpha square plus beta square plus 2b minus a square into alpha beta by beta square. Okay, this is nothing but you have the value for alpha square plus beta square, which is a square minus 2b. You substitute it, what you will get is, you look at the numerator, these two terms are exactly negation, right? This is plus, this is minus. Okay, a square minus 2b, 2b minus a square, which means numerator is 0. So you don't need to worry about beta square, it is 0 value anyway. Okay, that means if you substitute alpha by beta, this equation is 0, which means alpha by beta is the root of the given equation, right? Okay. Next, let P and Q be the roots of x square minus 3x minus 2 equal to 0 with P is greater than Q. Okay. If a uh, subscript, this is n is subscript, an equal to p to the power of n minus q to the power of n for n is greater than 1, then a20 minus 2a18 divided by 3a19 is what? Okay. So problem looks complex, but uh, uh, yeah, this is very easy. If you look at, let me show you. PQ are roots of this equation, quadratic equation. Okay, you substitute P. What you will get is P square minus 3P minus 2 equal to 0, or P square minus 2 equal to 3P. Right? Next. Similarly, Q square minus 2 also will be equal to 3Q. Okay. P plus Q is sum of roots, which is 3, minus of minus 3, which is 3. Product of roots PQ equal to minus 2. Okay. So you take the LHS. A20 minus 2A18 divided by 3A19. Correct? Substitute the values are p to the power of 20 minus q to the power of 20 minus 2 into p to the power of 18 minus q to the power of 18 divided by 3 into p to the power of 19 minus q to the power of 19. Right? Now you take common things. P to the power of 18 you can take common from these two terms. Then you will get p square minus 2. Okay. Q to the power of 18 if you take, you get q square minus 2q. Okay. So this is nothing but p to the power of 18 into p square minus 2 is nothing but 3p. So you substitute 3p. So 3 p to the power of 19 minus 3 q to the power of 19. And the denominator and numerator are exactly same. Which means the expression is 1. Okay. So this is how all the polynomials and quadratic equation problems you need to solve. These are the tricks actually. Okay. There are 4, 5 basic tricks. If you learn, I think you can solve all the Olympiad, at least easy questions. If not the advanced questions, you can easily solve the easy questions. Okay. Now, alpha, beta, gamma, theta are roots of x power 4 minus 3x square plus x plus 2 equal to 0. Then, equation having roots, okay, these 4 roots, alpha plus beta plus gamma by theta, basically sum of 3 roots by the other one, okay, the 4 roots. Okay. Now, let's find out. So we know that alpha plus beta plus gamma plus theta equal to 0 because there is no x power 3 term, right? You get minus x power 3, x power 3 coefficient is what? Sum of these 4 roots, which is 0. Okay. Which means, okay, which means alpha plus beta plus gamma equal to minus theta, correct? So if you substitute here alpha plus beta plus gamma as minus theta, this is minus 1, correct? This is minus 1, minus 1, minus 1, minus 1. All 4 are minus 1s, which means what we are looking is a polynomial with 4 minus 1s as roots, okay, which is x plus 1 whole power 4. That's answer, right? Next, the problems actually looks complex, but once you know the method, then you need to apply these methods when you get similar problems next time. Okay. Now, given that real numbers s and t satisfy 19s square plus 99s plus 1 equal to 0, t square plus 99t plus 19 equal to 0, and st is not equal to 1. Okay. Find the value of st plus 4s plus 1 by t. Okay. So, yeah, let's do. S of x, basically I am calling S of x this expression because it is written in the terms of S, right? So S of x equal to 19s square plus 99s plus 1. Okay. Let's find out what is the value of S of 1 by t. Okay. So S of 1 by t is nothing but 19 1 by t whole square plus 99 1 by t plus 1, which is nothing but 19 by t square plus 99 by t plus 1, which is 19 plus 99t plus t square by t square. Okay. Correct. So if you see the second expression here, numerator, okay, this is nothing but this expression, right? Okay. So 1 by t is root of s of x, correct? This is what we proved because this is given as 0. This is given as 0. So numerator is 0, correct? So this is a root. So s plus 1 by t equal to minus 99 by 19, correct? And s into 1 by t equal to 1 by 19. Okay. Now we know these two values. You find out from the given expression basically how to get with these two values, right? st plus 4s plus 1 by t equal to s plus 4 into s by t plus 1 by t. Okay. Now you combine s plus 1 by t plus 4 into s by t. Okay. S plus 1 by t is nothing but minus 99 by 19. Okay. Plus 4 s by t is 4 by 19. So which is equal to minus 95 by 19, which is minus 5. This is the answer. Okay. Next. Given p plus q equal to 198, find the integer solution of the equation x square plus px plus q equal to 0. Okay. P plus q equal to 198. That's given. Okay. Now let's see. Let a comma b are roots of this equation. So a plus b equal to minus b, ab equal to q. We know this. Okay. Now p plus q. Okay. What will happen to p plus q? P plus q equal to minus a minus b plus ab. Okay. Now I just want to try to make it factorize basically and see. Okay. So if I take a common here, a and minus a and ab, a common, then it is b minus 1, then minus b already there. Okay. Minus b plus 1 I am adding, minus 1 I am adding. Okay. Now I can factorize it. This will become a into b minus 1 minus 1 into b minus 1 plus 1, which is equal to b minus 1 into a minus 1 plus 1. Okay, which is equal to p plus q is given as 198. So this is equal to 198. Okay, now b minus 1 into a minus 1 equal to 199. Okay, this is minus 1 actually. Okay, what will remain here is minus 1, because if you see here, minus 1 into minus 1 is plus 1. So plus 1 is taken, so minus 1 will remain, and minus 1 will go to other side, it will become 199. So this equation is correct. If there is a mistake here, this is minus 1. Okay, so b minus 1 into a minus 1 equal to 199. Okay, this is correct. And what we are finding is the integer solutions for and a comma b are integers. So obviously 199 has any factors? No, this is the prime number, right? So a minus 1 into b minus 1 has to be either minus 1 into minus 199 or 1 into 199. So this is the only option, right? Let's take case 1. Let's take a minus 1 into b minus 1 equal to minus 1 into minus 199. Then in this case, a will become 0 and b is minus 198. Case 2, a minus 1 into b minus 1 is 1 into 199. Okay, in that case, a becomes 2, b becomes 200. Okay, so the solution set is a comma b is either 2 comma 200 or 0 comma minus 198. This is the solution set. Okay, next. Given that a comma b are integers with a greater than b and two roots alpha comma beta of the equation 3x square plus 3 into a plus bx plus 4ab equal to 0, satisfying the relation alpha into alpha plus 1 plus beta into beta plus 1 equal to alpha plus 1 into beta plus 1. Okay, find all the pairs a comma b of two integers. Okay, so the problem looks complex, but you have to break down the problem. First is it is given alpha beta roots of equation, it is given, so we can derive the relation between alpha beta and ab, right? Then substitute here and then see what happens. Correct. So this is the given expression, right? Alpha into alpha plus 1 plus beta into beta plus 1 equal to this value, which is nothing but uh, alpha square plus alpha plus beta square plus beta equal to alpha beta plus alpha beta plus 1. Okay. Now, if I simplify, what you will get is alpha square plus beta square equal to alpha beta plus 1. Okay, which is nothing but alpha plus beta whole square equal to, okay, I am adding 2 alpha beta here on both sides, so it will become 3 alpha beta plus 1. Okay, now hold on, now you have the quadratic equation here, alpha beta are roots, so we know that alpha into beta equal to 4ab by 3, 4ab by 3. Okay, alpha plus beta equal to minus 3 into a plus b by 3, which is minus a plus b, minus of a plus b. Okay, now we have to just substitute here, right? So if you substitute, what you will get is alpha a plus b whole square equal to, okay, 4ab by 4ab plus 1. Okay, 3 and by divided by this denominator 3 gets cancelled. Okay, so now you take this 4ab to the other side. What happens is a minus b whole square equal to 1. Correct? So which means a minus b equal to 1 or b equal to a minus. So this is the relation finally you got between a and b. Correct? Now a is greater than b. Okay, and b is 1 less than a basically. So the relation given, inequality given here is also satisfied. Okay, so determinant of this one, now we need to just find out there are infinite solutions we'll get from this one equation, right? We need one more relation to limit it. Okay, now determinant, that is, if you take this equation, quadratic equation, determinant should be always positive. Okay, otherwise you get complex numbers or imaginary numbers as roots. Okay, for real roots, determinant should be positive. The determinant is 9, 3 square, that is 9 into a plus b whole square minus 4ab term, that is 4 into 4ab into 3, that is 48ab. It should be greater than or equal to 0. Okay. So this is nothing but 3 into a plus b whole square greater than or equal to 16ab, or okay, or 4 into a plus b whole square minus a minus b whole square. Okay, 16ab I can write it like that. Okay. Now, okay. Now 3 into a plus b whole square is greater than or equal to 4ab, because a minus b is how much it is? A minus b is 1, correct? A minus b is 1. So if I replace here, I'll get 1. 3 into a plus b whole square is greater than or equal to 4 into a plus b whole square minus 4. 4 into 1, 4, right? Okay. That means 4 is, okay, if I take 4 other side, 4 is greater than or equal to a plus b whole square. Okay. So a plus b is in between minus 2 and 2. Okay. From this is what we can conclude. Now we have two relations basically in a and b. With this, we can very easily solve the problem. Solutions that you can get, right? So in place of b, you substitute again a minus 1. So it will become 2a minus 1. So 2a is between minus 1 and 3. 2a is between minus 1 and 3. So integer values of a are, okay, 0. Okay, because if you take minus 1 here, it will become 2a should be between minus 1 and 3. Okay. If you take 2a equal to minus 1, then a equal to minus 1 by 2, which is not integer value. So you have to take 2a as 0 and 2. Okay, 2a equal to 0, a equal to 0, 2a equal to 2, a equal to 1. These are the two integer values possible. Now for this a values, you find out the b values. Okay, so a comma b is either 0 comma minus 1 and 1 comma 0. These are the two values. Just substitute these values into the equation and verify it. Okay, this is most important thing. Okay, yeah. Next, two polynomials p of x equal to x cube plus ax square plus bx plus c has the property that mean of its zeros and product of its zeros and sum of its coefficients are the same. Also, p of 0 equal to 2. Find ABC. Okay. So he gave actually a lot of information. We have to just put them in equations first. Okay. P of 0 equal to C he gave. P of 0 equal to 2. Okay. P of 0 is what? If I put 0 here, x cube is 0, x square is 0, x is 0. So only C is remaining. P of 0 equal to C. So C equal to 2. So one value we got already. Next. Alpha, beta, gamma roots of P of x, then alpha plus beta plus gamma by 3. Okay. That is average. It is given, right? Mean of its zeros. That is alpha plus beta plus gamma by 3 equal to alpha, beta, gamma. Okay. Which is equal to a plus b plus c plus 1. Okay. Sum of its coefficients. 1 plus a plus b plus c. Correct. Okay. Now c equal to 2. You substitute, then what you will get is a plus b plus 3. Okay. Now these are all equal. That's what is given, right? So alpha plus beta plus gamma is nothing but minus a. So minus a by 3 equal to alpha beta gamma. Okay. Alpha beta gamma is nothing but c, constant term, c by 1. So sorry, minus c by 1. So minus c. These two are equal, which means a value is 6, right? From this we can derive. Now we got a. Now we just need b. We can substitute any of this actually. Alpha plus beta plus gamma equal to a plus b plus 3. Correct? A plus b plus 3. Okay, which means alpha plus beta plus gamma is minus c, which is minus 2, equal to 6 plus b plus 3. So b equal to minus 11. So we got all the three values. Okay, a equal to 6, b equal to minus 11, c equal to 2. Okay, next. What is the product of real roots of this equation? Okay. Okay. So if you look at the x square plus 90x is common in both sides. Okay, so you replace this with some constant, or you replace whole expression with some constant, so that this also you can rewrite into the terms of that same constant. Correct? So let's t equal to x square plus 90x plus 2027. So the given expression will become t by 3 equal to square root of t plus 28. Okay, squaring on both sides, what you will get is t square equal to 9 times t plus 28, or 90 plus 252. So therefore, the quadratic equation new one you will get is t square minus 90 minus 252 equal to 0. Okay. Now factorize the polynomials. Minus 252 you can write it as 20 minus 21 into 12, and minus 21 plus 12 is 9. So that way you factorize, what you will get is t minus 21 into t plus 12 equal to 0. So t equal to 21 or minus 12. Okay. Now you take case ones, both cases. For t equal to minus 12, okay, t equal to minus 12, x square plus 90x plus 27 equal to minus 12, or x square plus 90x plus 2038 equal to 0. Okay. So if you see this determinant, you check the determinant, you will get negative value. So it don't have a real root. Okay. Approximately you take 90 square is uh, 8100, and 4 into 2038 will be more than 8100. Okay. So b square minus 4ac is negative. Okay. For t equal to 21, x square plus 90x plus 2027 equal to 21, or x square plus 90x plus 2006 equal to 0. Okay. So this one you can check the determinant, it is positive. So it has real roots. So the product of real roots is always, you don't need to find out the roots, right? Constant term is the product of real roots. So product of real roots equal to 2006. That's the answer. Okay. Yeah. Yeah, that's all. These are the some of the collection of IOQM problems, or some of the mathematics Olympiad polynomial problems. Hope these are all will give you a lot of different ways of working on polynomial. This is definitely above your regular class polynomial. Okay. But these are all required if you really want to target your Olympiad or engineering entrance. I'll start collecting more and more problems in each chapter, like polynomials. Whatever chapter I'm going to teach, I'm going to collect and present them as I make some good collection of problems and good set of problems which deal with a different kind of solutions. Thank you.